Hello there everybody. Today I'll be showing you the Sieve of Eratosthenes. Now, Eratosthenes was a Greek mathematician a very long time ago, and he created this method of trying to sieve out all the prime numbers. So there are two types of numbers I'm going to be talking about in this video. There are prime numbers and composite numbers. Prime numbers are numbers which can be divided by itself and 1, and composite numbers are the opposite. So these are numbers that have factors of more than just 1 and itself. So the way this works is that we're going to eliminate all the composite numbers, we're going to sieve them all out, and then what's going to be left is the prime numbers. So I'm going to show you how this works. So first we look at 1. Now clearly 1 isn't a prime number. In case you're wondering, a prime number is to be divisible by 1 in itself. 1 is divisible by 1, which is itself, so it only has one factor, so that means it is not a prime number. So I'm just going to mark it out. Okay, so any number I'm marking red is going to be composite, and numbers in green are going to be the prime numbers, which is what we want. Okay, so the sieve then says look at the next number. So we have 2. 2 is a prime number as it's only divisible by 2 and itself. So we're going to leave it as green. Now what we need to do is we need to square this number, which is 4, and then we need to find out all the multiples of 2, and then we can cross all the multiples off. So any multiple of 2 is a number that ends in 2, 4, 6, 8, or 0, which are the even numbers. And these even numbers are all composite, so we're going to cross them all out. So if you ever see a number that ends in 2, 4, 6, 8, or 0, you know for a fact it cannot be prime, unless it's 2. 2 is only the prime number that is even. Okay, next we look at 3. 3 is divisible by itself and 1, so 3 is a prime number. So now we want to square 3, which gives us 9, and that means 9 is not a square number. No, 9 is a square number. It means 9 is not prime. Now what we need to do is find the multiples of 3, every single multiple of 3. So I'm just going to cross off all of them one by one. An easy method of telling whether or not a number is divisible by 3, if you add up all the digits, you should get either 3, 6, or 9. So for example, if we look at 99, we add the digits up, you get 18, which is 1 and 8. Add up 1 and 8, you get 9, which is 3, 6, or 9. So that means it's divisible by 3. So that's a cool method to remember. I believe I've got most of them. I'm just going to double check. Okay, I think that's all of them. Yeah, that's all of them now. Yeah, there we go. Next on the sieve, we look at the next number that isn't crossed off already, which is 5. 5 is divisible by itself and 1, which means that it is a prime number. 5 squared is 25, and if we move up, we can look at and see all the numbers that are end in 5 or 0 must be composite, so we're going to cross them all off. So let's do that again, and any number that ends in 5 or 0 is divisible by 5, so we can cross them all off. Okay, next number to look at is 7. 7 is a prime number as it starts with 7, as it's divisible by 7 and divisible by 1. If we square it, we get 49. Now you're probably wondering why I keep squaring it. That's because all the way that the sieve works is that every single composite number between every single multiple of n between n and n squared have already been crossed off. So 49 is actually the first multiple of 7 that hasn't already been crossed off, because you can see 14 has been crossed off, 21 has already been crossed off, 28 has been crossed off. So that's the way the sieve works. It crosses off all the numbers between n and n squared, which are multiples of n. Okay, so now we can just cross off all the multiples of 7. So 7, then we have 14, which is already done, and we can go straight to 49, then 56, which is already done, then 63, which is already done, 70, which is already done, 77, we can cross off, 84 has already been done, 91 we can cross off, and 98 has already been done. There we have it. Now this is where the sieve gets the most interesting. We move on to 11. 11 squared is 121, which is greater than 100. And what I said before is that the sieve, it tells you all the prime numbers after n squared. So since n squared is greater than 121, we know that we found all the prime numbers within our range. Our range for the sieve was between 1 and 100, and we found we've sieved them all now, and any number left is now a prime number. So that's great. I could just cross them off. That'll take ages, but I'm just going to do it quickly. So just to recap everything. Any number that ends in 2, 4, 5, 6, 8, or 0 are automatically composite numbers, apart from 2 and 5. And remember, for I keep forgetting, for the Sieve of Eratosthenes, we need to remember that it tells you all the primes between n and n squared have already been crossed off. So if we look at doing the same for between 1 and 200, we'll be looking at all the multiples of numbers between 1 and 14, because the square of 14 is 196. We do 196, and if we look at 15, the square of 15 is 225, which is outside of the range. So we only have to look at multiples of numbers between 1 and 14. And once you've got the multiples of numbers between 1 and 14, you've actually sieved out all the composite and all the composite numbers and all the prime numbers, which is good. And also, this the Sieve of Eratosthenes can be turned into a computer program. So in a future video, we're going to make a program that tells us what prime numbers are between a certain range. So we can look at 1 in 1,000, 1 in a million, 1 in a billion. We can just keep creating a bigger range, and the sieve should work each time. So there you have it. That's the Sieve of Eratosthenes. I hope you enjoyed this video, and please leave a like, and remember, maths is the way.